In our previous video, we dealt on rationalizing the denominator, where we say to rationalize the denominator, we multiply the numerator and the denominator by the conjugate of the denominator. But now in this lesson now, we want to learn how to determine the square root of a Surdic number. Now, if you are given 7 plus 2 root 10, and we are asked to evaluate the square root of this value, the first thing we do is we say let the square root of 7 plus 2 root 10 to be equals to root m plus root n. Now this is plus and this is plus. If this one is negative, definitely the square root will have negative. However, we are dealing with plus and this should be plus also. Now we are saying that the square root of 7 plus 2 root 10 is equals to root m plus root n. Now to move further, now we can say if we square both sides, 7 plus 2 root 10 will be root m plus root n all squared. Now if you perform root m plus root n squared, this will give us root m plus root n multiplied by root m plus root n. And if we perform our algebraic expansion here, it will give us m plus 2 root mn plus n. Therefore, we can say this will give us 7 plus 2 root 10 is equal to m plus 2 root mn plus n. Now I can collect like terms and say m and n comes together and the square root stays at one end. So that means we're saying 7 plus 2 root 10 is equals to m plus n plus 2 root mn. Now with this done, we can now evaluate the equality of surds, where we say the whole number is equal to the whole number, the surds is also equal to the surds. So in essence, we are saying from equality of surds, m plus n is equals to 7 and 2 root mn is equal to 2 root 10. So with this, we have two equations. So we are saying this one is equation 1 and we can call this equation 2. Therefore, from equation 2, to simplify further, if we divide both sides by 2, we are saying that root mn is equals to root 10. Therefore, mn is equals to 10. And this is still an extension of equation 2. So we can nullify this now. So now we have two equations. We have m plus n is equals to 7, equation 1. mn is equals to 10, equation 2. Now all we just have to do is to solve equation 1 and 2 to evaluate for m and n. Now if we go from equation 1, we can say that m is equals to 7 minus n. And if we call this equation 3, if we substitute equation 3 into equation 2 will give us 7 minus n multiplied by n is equal to 10. Now if we open the bracket, we have 7n minus n square is equals to 10, and n square minus 7n minus 10, or rather you can say minus n square plus 7n minus 10 is equals to 0, and then if we multiply all through by minus 1, n square minus 7n plus 10 is equals to 0. Now if we solve this quadratic equation now, we will have, by factorization, n minus 5 into n minus 2 is equals to 0. So we are saying n can be equals to 5 or n is equals to 2. Now if n is equals to 5 and n is equals to 2, then we recall again from equation 3 that m is equals to 7 minus n minus 2 minus n rather. So if n is equals to 5, our m is equals to 7 minus 5, which is equals to 2, and if n is equals to 2, our m is equals to 7 minus 2, which is equals to 5. Now we are saying some correlation here. We have 5 and 2, and at the same time we also have 2 and 5. So therefore we can pick one and say m is equals to 5, n is equals to 2, or m is equals to 2, n is equals to 5. That means we are saying that the square root of 7 plus 2 root 10 is equal to root m plus root n from the beginning of our expression. Square root of 7 plus 2 root 10 is equals to root m plus root n. And if m is 5 and n is 2, we have 5 plus root 2. And if m is 2 and we have n to be 5, we have root 2 plus root 5. Now it's still the same thing. So the square root of this are this plus this twice, because they are occurring at the same time. Let's take another question. We are asked to evaluate the square root of 14 minus 4 root 6. 14 minus 4 root 6. Now, so in the same vein that we did, we say let the square root of 14 minus 4 root 6 be, we can still use m, and we can also still use n. Now this is minus, okay? If it is minus, like we explained earlier, square root also will contain a negative sign. Well, let's make it different and let's use p and q. So if the square root of 14 plus 4 root 6 is equal to root p minus root q, therefore we are saying that 14 plus 4 root 6 is equal to the square of root p minus root q. And if you find the expression of root p minus root q squared according to algebraic expansion, this will give us p plus q minus 2 root p q. So therefore we are saying that 14 plus 4 root 6 is equal to p plus q minus 2 root p q. So do our equality of sorts again. P plus q is equals to 14, and 4 root 6 is equal to 2 root pq. Now into something, this should be negative, please. Negative. The question says 14 minus, so this is 14 minus 14 minus 14 minus. So yes. Okay, let's proceed now. So we have two equations. P plus q is equals to 14, and likewise 2 root pq is equals to 4 root 6. Now let's express pq in terms of a whole number. So now if you divide both sides by 2, we find out that pq, the square root of pq, is equals to 2 root 6. And if you take pq, now will be, if you square both sides, we will have pq on the left hand side, and we have 2 root 6 squared on the right hand side. And 2 root 6 squared is 2 squared multiplied by 6. That is 4 times 6, which is equals to 24. Therefore we have two equations. We have equation 1 and we have equation 2. Let's bring them together. So p plus q is equals to 14, pq is equals to 24. Now just like we did earlier, we solve equation 1 and solve equation 2. So we say from equation 1 we have that q is equals to 14 minus p. We call this equation 3. We substitute equation 3 into equation 2, and the resulting equation 2 will give us p into 14 minus p is equals to 24. So if you solve this, we have 14p minus p squared is equals to 24, and if we bring them all together, minus p squared plus 14p minus 24 is equals to 0. Therefore, p squared minus 14p plus 24 is equals to 0. This involves multiplying the line by minus 1. So with that done, we have two values of p. P is equals to 2 and p is also equals to 12. Now we recall again from equation 3 that q is equals to 14 minus p. Therefore, if p is equals to 2, our q will be 14 minus 2, which is 12. And if p is equals to 12, our q is 14 minus 12, which is equals to what? 2. So we have p is equals to 2 and q is equals to 12, or we have p is equals to 12 and q is equals to 2. Now we recall again that the square root of 14 minus 4 root 6, okay, is written as root p minus root q. Now, because of this negative sign, we are going to have two results. In our previous example, it was positive, so it was commutative. However, this place we take the first result and say this is root p, that's root 2, and root q, that's root 12. And okay, p, which is 12, minus q, which is 2. So we have two results, root 2 minus root 12 and root 12 minus root 2. If we simplify root 12 further to its basic form, it's going to give us root 2 minus 2 root 3 and 2 root 3 minus root 2. So with this we have learned how to find the square root of a Surdic number. Give it an expression. If it has a negative sign, it has a negative sign, and if the question is positive, therefore we'll use a positive sign. And then we move on to solving the square both sides, use the algebraic expansion. Thereafter we do our equality of sorts, and then we move to solving the two equations. And once we solve the two equations, we find the two unknown values and we'll substitute the values.